Here is a video that has some GED questions that pertain to graph and functions. So in this video, you'll see some questions that have to do with coordinate geometry, slope, y-intercept form, point slope form, parallel and perpendicular lines. So all these kind of have to do with graphing. And then sort of as a separate thing, we have functions and rate questions. These questions come from GED, and you will see very similar ones on the GED. So one of the things that's really important that I highlight a lot in this video is using the formula sheet. So over here is just a screenshot of the whole formula sheet. We're actually going to be using the bottom of the formula sheet, and I'm going to highlight these ones here that have to do with slope. And total cost actually comes up, but you actually can't use it. So I kind of mention it as like it might be useful, but you'll see in the cost questions that we have today, we're not going to use this at least all by itself. Okay, so let's go ahead and get started. Question 1. All right, it says points J, K, and L are plotted on the coordinate grid. You can see them here, J, K, and L. What are the coordinates of the points on the coordinate grid? Well, if you remember, coordinate pairs are ordered pairs here. The X comes first and then the Y. So this is negative values of Y. So this is the Y line. So that's negative Y. This is going to be positive Y. Here you've got positive X. You can see they've written X, and so this will be like negative X towards this side. So if we just take the very first one as J, the very first thing is you want to figure out, well, it looks like it's going to be negative 4 and then positive 1. So if you look down here, the only one that fits is B. And sure enough, let's just double check that that's the answer. Is K 0 and 3? Well, yes, the X coordinate is 0 and it does go up 3. Is the L coordinate 3 and 2? Yes, it goes over 3 and down -2, so 3, -2. Our answer here is B. Okay, next question. What is the slope of a line represented by the equation 3x plus 4y equals 8? All right, so if you look down here, again, this is a screenshot of the formula sheet. We need to have this equation in the slope-intercept form of an equation of a line. In other words, we need to set it so that we have y all by itself. What does y equal? Because when we figure that out, we can determine what m is, and m is the slope, which is what we're trying to find. And b is the y-intercept, so it's where it crosses the line. So where this crosses this right there is going to be B. That's your y-intercept where it crosses. All right, so maybe let's just dive into the problem here. So if we rewrite it, which is always a good practice, because just like on the real GED, it'll be on a computer screen. You have to copy this onto paper in order to figure out. So let's go ahead. We want to isolate y all by itself. We need to get y. So the very first, we need to move everything that's non-y to the other side of the equal sign. So let's subtract 3x here. And we'll do that from both sides. So we're going to have these cancel out. And now we've got positive 4y, we won't write the positive, equals 8 minus 3x. Now, that's just the way that I wrote it. Normally, you always want to write the x first, and plus, because we have the x, I'm gonna switch these around. This is a positive, okay? So if I switch these around, this is going to become 4y equals negative 3x plus 8. All right. So now we're going to divide by. We need to isolate y here. So what's happening to y when we write a letter and a number right next to each other? We are implying that there's multiplication keeping them together. This is 4 times y. So in order to isolate y, we have to do the opposite of that, which is divide by y. Divide by 4. Okay, so if we divide each side by 4, and we have to actually kind of do it like this, these cancel out, and sure enough, we've isolated y. Y is going to equal a negative 3/4 x, and 4 fits into 8 2 times. plus 2. So there's your y equals mx plus b version of the equation. And here is our slope. This is m, negative 3/4, which is right here. Okay? All right, question 3. Chelsea designs beaded bracelets. The equation P equals 7 plus 0.05B can be used to find the price P of a bracelet that has bead beads. What does the number 0.05 in the equation represent? So again, as I highlighted at the beginning, you might want to say, well, this is the total cost and try to use this one. And in a way you can. If we look at this, and I've changed these into words here, that the price is equal to a flat rate plus the price per bead. So the price per bead is equal to the number of units times the price per unit. In other words, price per unit, the unit here happens to be a bead. So if we look at our answer choices, 0.05, is it the price of the bead? Is it the price of the bracelet? The number of bracelets made, and the number of beads in a bracelet. Well, if we write this whole thing here as they have it, this is P equals flat rate of $7 plus 0.05 times B. This is going to be the price of a bead, price of one bead. Okay? B is equal to the number of beads. So our answer is here. P is the price of each bracelet. That's this one. The number of bracelets made, we don't know. That would be, what the coefficient or something here. And the number of beads in a bracelet, again, is right here. That's this one. Okay? So our answer is, hey, the price of each bead is equal to 5 cents. Question 4. Kirsten walks up 6 flights of stairs to her office each morning as part of her exercise routine. She walks the first 3 flights, rests for 30 seconds, walks the next 2 flights at the same rate of speed as she walked the first 3 flights, rests again for 30 seconds, and then walks the last flight of stairs at the same rate. Which graph represents Kirsten walking up the stairs? All right, so if I'm going to tackle this question, the first thing I'm going to do is I'm going to actually decode this. What in the world is going on? Take it step by step. Okay, so if we take it, she walks 3 flights of steps, then she takes a break. Then she goes 2 more flights, then she takes a break, and then she goes the final flight. That's what's going on, all right? So if you look, and we compare the answer choices. So A and C kind of look pretty similar, right? That we've got this straight line up and down. B and D also look kind of similar. And instead of a straight line up and down, it has a horizontal line. All right, so that's kind of the first question. If time is on our x-axis at the bottom here, when you have a straight line up and down, this is the time stopped. It's like for this one instant, somewhat makes it up, goes up without losing any time. So she's increasing her height without it taking any time. Well, that's not what's going on. If we look over here, what's happening is she's increasing her height, going up the steps, and then she stops. Time still continues for 30 seconds. Okay, so these are the ones we want. So we can immediately get rid of A and C. Okay, now what's the difference between B and D? Well, if you look, the lines here going up are all the same, right? We're here, this one's longest, second longest, and shortest. And if you remember, she goes up 3 flights, takes a break, then 2 flights, then 1 flight. So this one could be 3, this one could be 2, and this one's 1. Where this one over here is likely 3, 3, and 3. So D is going to be our right answer. Okay, just want to make another extension here because this is a rate problem, even though they never mention it. And slope is equal to rate. So I just kind of drew this here. Slope is equal to the rate or the speed. So if you have a line here like this one's fast or much faster compared to this one. If the line is kind of slow or gradually increasing up, it's going to be a slow rate. So I just want to make that extension when sometimes you get rate problems where they give you two different graphs and you have to say which one's moving faster, and you want to look at the steepness or the pitch or the slope of the line. Okay. Question 5. What is the equation of the line that has a slope of -7 and passes through the point 48? All right, so this is one where we are going to use the point slope form of the equation. And that's this one right here. Y minus y1 equals m in parentheses x minus x1. So what this means is the point slope form, we know the slope, so this is going to be m, and this represents a point. So the point slope form is for when you know the slope and you know a point. So let's write it. Y minus y1 equals m times x minus x1. So over here, this is going to be x1, 4 is going to be x1, and 8 is going to be y1. So let's put these numbers in. Y minus y1 is 8 equals the slope, which is -7, times x minus x1, which is going to be 4. All right, so the first step is we have to distribute this -7 across the parentheses. So -7 times x, and then we're going to do -7 times -4 here. So -7 times x is -7x. -7 times -4 is +28. Okay? And we have y minus 8. So let's take a second and let's look at our answer, how our answers are framed. They're not in y equals mx plus b format or the slope-intercept form, but we're going to have to go through that. We're actually going to end up setting our equation equal to this, and then we're going to subtract this to bring it over, because our answer choices have x and y on one side and then our constant or our y-intercept on the other side. So we've got y minus 8 equals a -7x plus 28. So we need to move this -8 over to here so we can isolate y by itself. So we're going to do the opposite of subtracting 8, which is adding 8 to both sides. Okay, so now we've got our y-intercept form. Y equals -7x, and 28 plus 8 is plus 36. All right, again, this is not one of our answer choices. We need to move the 7x over to here. So we're going to do that by adding 7x. So this is going to be y plus 7x. These cancel out, equals 36. So let me write that a little bit neater. Y plus 7x equals 36. So it's not exactly the same, but anytime you're adding, 2 plus 3 equals 5, and 3 plus 2 equals 5. So we can switch these around. 7x plus y also equals 36, which is one of our answer choices right here. Okay? All right. Number 6. What is the equation of the line that passes through the points -3, -2, and 1, 6? All right, so this is about as advanced as it gets. We're going to use all three forms of these slope formulas down here. So the first one we're going to use is the slope of the line. This is effectively your rise over your run, right? So we're going to use that, the change in y divided by the change in x, to find m. Once we got m, then we're going to use the point slope form, just like we did in the last problem, to solve it for y equals mx plus b, which is the form of our answer. If you look at our answer choices, they're in that slope-intercept form, y equals mx plus b. So let's find the slope first. So the equation to find the slope is y2 minus y1 divided by x2 minus x1. So here's one of the most important steps, is labeling these. If you have to write these down, please do so. So this will be x1 and this will be y1. This will be x2 and this will be y2. All right, so starting at the top, y2 comes first. So this is going to be 6 minus y1, which is a negative 2, divided by x1, which is 1, minus x1, which is negative 3. All right, so I always teach subtraction as adding the opposite. I deal with students a lot, and I see that they will guess, well, here the answer is 4, or no, maybe it's negative 2, or it's negative 4. They're just kind of thinking it's easier than it is. And really what you should do is add the opposite. So the first number you keep the same. This negative you're going to turn into an addition or add, and then you're going to change this sign to a positive. So now it becomes 6 plus a positive 2. Same thing here on the bottom. Well, let's just finish that out. 6 plus positive 2, well, that's 8. Okay? And then 1 minus a negative 3 is equal to 1 plus a positive 3, which is 4. Okay? So 8 divided by 4 is 2. So our slope is 2. M equals 2. So now we can use the point slope form of the equation. I'm going to do that over here. So this is y minus y1 equals m x minus x1. Again, I'm taking this from the formula sheet. It's right here. Okay? So let's plug these numbers in. We can use the same one. You can use these ones here. You would get the same answer if you did this one, but we might as well do the one that we've already have labeled. So y minus y1 is negative 2. Okay? Negative 2, y1 equals m, which is our slope, is 2, times x, and then minus x1. So minus a negative 3. All right. So first step here, you normally don't write minus a negative. So again, let's convert these into the much more usable form, which is where, again, you're going to add the opposite. So let's change this to y plus a positive 2. It's equal to this, okay? They have the same thing. It's just much easier to deal with. And this will become 2 times, well, we don't normally write x minus a negative 3. We would just write x plus 3, or x plus positive 3 if you want to really finish it out. I know I kind of did an extra addition here. So now our next step, our additional positive over here, if we multiply this 2 times x and then 2 times 3 to distribute this 2 across this parentheses. So this is going to be 2x. 2 times x is 2x, and 2 times 3 is going to be 6. So now we've got y plus 2 equals 2x. So we're going to subtract 2 to isolate x, and we end up with y equals 2x plus 4, which is A right here. So quite a bit. Again, notice we used pretty much all 3 forms of the equation. This is a good one to make sure if you get this one on the test. I might flag this. I might guess it, flag it, come back, just so you can. This one takes some time. If you're really strong on this stuff, then you can blaze through it, and time won't be an issue. But might be one you hold off and make sure you have enough time for. All right. Question 7. What is the slope of a line that is perpendicular to 5x minus 2y equals 1? All right, well, before we dive into this problem, let's talk about parallel lines and perpendicular lines. So parallel lines are right next to each other. Think railroad tracks. They're going to have equal slopes. So if a slope has on line 1 is 1/3, the other line, if it's parallel, will have the same slope. Perpendicular lines, we say, have opposite reciprocal slopes. Okay, and by opposite, we mean change the sign. So in this case, here, if it's positive, make it negative. Okay, reciprocal, we mean flip it. So if it's 1 over 3, it'll be 3 over 1. And again, you do the opposite to make it negative. If it's 5, you can also write 5 as 5 over 1. So when you flip it, it becomes 1 over 5. And then again, change the sign, make it a negative. If it starts off negative, like negative 2 over 7, a perpendicular line is going to be 7 over 2. Okay, so you'll change the sign to a positive here. Again, you don't normally write that. All right, so what we need to do here is we need to take this into the y equals mx plus b form, slope-intercept form, and then we're going to do the negative or the opposite reciprocal of the slope. Okay, so it's going to be the -1 version of the slope. Okay, that's going to be our step. So let's do the first step here. So let's start by writing our equation. 5x minus 2y equals 1. So we need to move this 5x over to here. So we're going to subtract 5x on both sides. These sides cancel out, and we end up with a -2y equals 1 minus 5x. So if you remember, what we want is our y equals mx plus b. We want our x's first before our b's or our constants. So I'm going to switch these two. So this is going to be -2y equals a -5x. There's a positive that's implied here, so I'm going to do plus 1. And so now let's isolate y. There's a -2. This what's implied here is multiplication. -2 times y. So we need to do divide by -2. And again, you'll do it on both portions here. So these cancel out, and we've got y is equal to 5 over 2. So we get rid of the negatives because a negative divided by a negative is a positive. So that becomes x. And then plus 1 divided by a -2, well, that's going to be minus 1/2. So there's our y equals mx plus b, but that's not what we're trying to find. We're trying to find what is the line that's perpendicular to this slope. So if m equals 5 over 2, a perpendicular line is going to be the opposite. It's going to be negative, and it's going to be the reciprocal. So we'll flip it. So we're looking here at B. All right, question 8. Tim is looking at 2 websites that allow customers to print their own designs on t-shirts. One website charges $24 per t-shirt plus $8 shipping. The other website uses the equation C equals 22N plus 12 to find the total cost, C, of printing N t-shirts. What is the difference in the cost of each website if Tim orders 10 t-shirts? All right, so we're comparing 2 different companies and how they have their pricing structure, okay? For both of them, what we have is the total cost is equal to the cost per shirt. So you need to know how many shirts you're buying, which is 10, and how much each shirt costs, plus shipping. So they each have a different cost per shirt and a different shipping rate. So website 1 is up here, okay? So cost, total cost, is going to be equal to $24, 24N, plus $8. Website 2 is cost, total cost, is 22N plus 12. Now again, N equals 10 on both sides. Okay, so hopefully, if you look down here, this is the formula sheet again. Here they say total cost. I just mentioned this because this total cost they're saying is the number of units times the price per unit. That's equal to this portion right here. You got your number of units, and your cost, N is your number of units, and 22 is your cost per unit. So that just gives you this. It doesn't give you the flat rate or the shipping. So unfortunately, their formula that they give you on the GED is not super useful. This is the one that you have to use. So let's go ahead and insert 10 into each of these. So this will be 24 times 10 plus 8. 24 times 10 is 240, plus 8 is $248. All right, so website 2 is going to be 22 times 10 plus 12. 22 times 10 is 220, and put that in the calculator if you have to, plus 12 equals $232. So what is the, it says what is the difference between the two? Well, we have to subtract them. So we're going to do 248 minus 232 to find the difference. 2 from 8 is 6, 3 from 4 is 1, and the rest are 0. So our answer here is this $16 difference between the two websites. All right, question 9. Which table represents a function? So having worked with a lot of students, I find these types of questions really are confusing unless you know what they're asking for and you know a little bit about functions. And so here's some background before we dive into answering this question. This is taken from the GED. They say students need to be able to represent or identify a function in a table or graph as having exactly one output for each input. Okay? So functions are like machines. And this is what is a representation of a function machine. So you have an input of X and it goes through some machine and it should output something. So like a toaster is an example of a function. You put your bread in. If you put it on a level 3, it should put out the same level of toasted bread every single time. If it doesn't, the function's broken, right? But if you put in the same type of bread, the same level 3, your bread should come out the same every way. If it doesn't, maybe your toaster's broken. In other words, maybe it's not a function anymore, okay? So here's the thing. Functions are consistent. Functions are predictable. They're not random. So the opposite of a function is randomness, right? It's things that don't necessarily make sense. There's no pattern to them. So now what other extension I want to make is if X is the input and we want them to have only one output for that version. So if you look at this, if the input is 0, you have X could be 0, it's twice. So we have X here is outputting -4. The next input of 0 is outputting +4. Well, okay, that's weird. Why? Why is the difference? This one is not a function because they have two output values for one input value. But what we want is a function that has exactly one output for each input. So this one is not a function. Same with this 2. Even we have two different 2's, but we have a -3 and a +3. This one is not a function. So let me prove a point to you down here. Okay? What if you had an input-output table like this? What if we have different versions of X, but they all output a 4? Does this work? Is this a function? And the answer is yes, because there isn't a duplicate version of any input. We have -3 and we have +3. The fact that they put out a 4 doesn't mean anything. So I called this a card reader function. So card readers, lots of schools, students have badges and the badges open the door, right? And so you have a bunch of unique students. That's the input. They all have a unique badge. And if the badge works, they all do the same thing. They all open the door. So this is a function. So let's go down. This is B. Notice we have +5 twice, but we have it outputting a -1 and a +3. Not a function. This is random. We don't know. Maybe you do a 5 again and a 2 pops out. We don't know. Let's look here. We have unique values: -5, -4, -3, 0. Again, these ones here are the same, but that's okay. We can have the same output if we have two different inputs. What we can't have is a -5 putting out something. If we have another -5 down here, it has to output -4. Okay, this one works. Let's make sure this one doesn't work. Again, -2, -2, have two different outputs. positive 2, two different outputs for the same number, for the same input. Doesn't work, okay? So the other way that you can sometimes see this is on a graph. I've seen this question asked like this, where you've got, this is X and this is Y. And so they'll give you kind of like, it looks like it's a straight line, but then they give you like the same value. We have X, let's say this is 4. X is now putting out, let's say this is 2 and this is like 6 up here. X now has 2 outputs. So this isn't a function because we have 2 outputs. There's a 1, 4 is the input, but it's outputting a 2 and a 6. So that's the other way that I've sometimes seen this question, or at least this skill asked, is in form of a graph. All right, last one, number 10. What is the value f of x, that's how you pronounce this, f of x equals 3x squared plus 4 when x equals -3? So let's talk about this f of x. This is kind of confusing for students. So if we just take this whole thing, the f is the generic name for the function. So we're saying there's a function. The x is the generic name for the input value, all right? The whole thing is the output value. So f of x is also equal to y, which is also equal to the output, which in this question at least is going to be equal to the answer, okay? What is the output? In other words, this f of x is in the form of a question, is what is the output for the function when the input is 3? Okay, they're telling you the input's -3. And so you're not going to insert a 3 for f of x. That's what I see some students trying to do. They try to do this f, and then they want to put a 3 here, and they end up getting confused because how do we solve with, now we have a variable on the outs, never seen an f here. That's not what we're trying to do. What we're going to do is just solve for it. It's 3x squared plus 4 when x equals a -3. This is ultimately a PEMDAS question, as most function ones are, or a lot of them are. So -3, that is squared plus 4. So PEMDAS tells us we have to do parentheses first and then exponents. So we're going to square this -3. So squaring is equal to -3 times a -3, not -3 times 2. So leave your constant out here. -3 times -3 is 9. Again, plus 4. 3 times 9 is 27, plus 4. 27 plus 4 is 31. So there you have it. I hope this was helpful.